Okay, so hi, this is my tutorial for CSCI 30A1. I'm Lucas Kramer, and for my tutorial I basically wrote a configuration file manager that basically helps with managing settings for your program. So large projects, large programs can get pretty complex, and they typically have a lot of settings and a lot of header files that you have a ton of pound-defined constants, but that is not exactly optimal because, for one thing, you kind of have your settings scattered throughout all the files, and if you just need to change something real quick, it's hard to go and do that easily for debugging or whatever. And pound-defines are not type checked, so it's very easy to accidentally write a float when you mean an int or something, or even like a string instead of an int, or something funny like that. If you just have a typo, it's very easy to cause errors like that, and that can often result in some pretty strange bugs that are very hard to find. Also, when you accidentally define something twice, that goes unwarned, usually with most compilers, and the second value will either just get overwritten by the first value or the other way around. And that can also lead to some strange bugs. And also just managing like nested includes of header files in general can just be tricky when you've got a lot of pound defines in them. And for a project like our robot simulator, that is definitely the case. And also, if you want to test something or debug something and just quick change one of those things, you basically have to open up the header file, find it, edit it, compile, run, and change it back, and then recompile again, which is really a lot of hassle. So what I wrote basically is a library that will read in, when the program starts, read in those things from a separate configuration file, which also has a much nicer format than pound defines, and it'll load those in at runtime, and it'll let you use those variables for configuring your project. So even though it's loaded at runtime, it's basically instantaneous when you actually run the program. And yeah, so as I said, it's a nicely readable data format. It also, one thing that's important is it performs type checking and redefinition checking, so I'll actually give you a warning or an error when you have something that's the wrong type or you've already defined it. And that also helps catch stuff where like you include a configuration file twice by accident. There's also a very easy way of setting values from the command line for testing or debugging or whatever, and you don't have to recompile, you don't have to change anything in any files or anything, so it's a lot easier that way. And also, there's multiple ways you can specify values, like you can specify ints as hexadecimal or octal or decimal, and you really have most of the capabilities of the CPU processor for just pure constants. And so the types that you can specify are ints, which you can write as decimal, hex, or octal. You can have a float, bool, char, or a string, which you can put in, have a variable be. Okay, so with that I have a small demo. So keeping with the theme of robots in this class, I wrote a small robot simulator. It's quite a bit simpler than the one that we're all working on, but basically, as you can see, it's just a robot that bounces back and forth between two walls, essentially, until it gets going too fast and stops. So one thing is, basically, in the project structure, I have the bin and source folders as usual, but I also have this folder called config. So in config, if I go into that, I basically have two files. They're both configuration files. I don't have a suffix for them that I usually use, but if I open them up, So if you take a look at this, so basically this is what a configuration file looks like. So yeah, you can have a string that you can define. This is basically including another file. So basically what that does is, so when you have an include like this, it will essentially open that file which you specify with this path. It's the path relative to the current directory. It'll open that path and load that file, and essentially you can think of it as like copying and pasting that file into replacing where that include is. Basically how the preprocessor works. And so you'll have access to all those variables too. So all the variables basically end up in one place, even if you have them in different files. Yeah, so that basically helps with organizing stuff better. And you can have characters, ints, float, bool. Bools you can write as true or false, or you can write 0 and 1. Yeah, also you can write as hex, or octal is just octal delay millis equals a constant. And it also, the 0x is optional, but it's kind of recommended just from a formatting perspective. And so I have macros defined, and so this is the header file for my configuration stuff. You don't really have to worry about configuration.cpp. It's really complicated, and yeah, so you don't need to worry about that really. But basically, if you just want to look at the header file for the interface, I have these macros defined. So basically what those look for is, if in your class you just have a globally defined value config table, which is basically a table holding a bunch of configuration variables, if you use these macros, it will look up from, it will automatically call one of these functions. So what these functions do is they basically take a config table and a string, which is the name of the variable, and they extract that from the config table and will return that value, and so you can use it in whatever program. And writing get int config of config and whatever the variable name is called is a little bit more verbose. So basically these macros are just a shorthand, and so you can just write get int of name, and it'll look for a config table named config in global scope or local scope or whatever you have it defined. So yeah, so then you can also set variables from the command line. Okay, so for example, I don't want to change. Okay, so acceleration is this variable I have set here. So that basically it tells it in the app. So okay, so this is basically an example of actually using a variable. So it's just get int, get string, get bool, all that, and there's a global config table named config in the class, which gets initialized by the constructor. And yeah, so basically in main, if I open that up, basically it by default loads the config table named specified from this path, so /config/default. So go up one directory from bin, and then look in config and open a file named default. And so this function load config, there's two versions of it. One just takes in a file name and it only looks at that file name. This version also takes in the argc and argv, which get passed into main. And so basically what that allows you to do is, it'll look through there. So if you say --use -config, so like if I run the program as /example --use config file, so it'll use whatever path you put here instead of the default one. And then the other thing is that you can do is set variables from the command line, so and change their value. So for example, float acceleration. So if I just run this again to get an example of, get an idea of how fast it moves. Yeah, so you can kind of see how fast that's accelerating. Kind of slow, but I don't know. So then, if you look here, so basically I'm multiplying the speed by acceleration, and then it's getting automatically converted back to an int. Or yeah, so then if I change that from the command line, so the syntax for this is then it's dash d, then the variable name. So dash d acceleration, and then float is the type, so you put that after that, and then after that you put the value you want to give it. So it was 1.5. Well, make it something big. So I could rate this as 5.0, or I could just write this as 5 or whatever, and you'll see that it goes a whole lot, accelerates a whole lot more after it hits there. Oh, and then I guess just kind of one funny quirk is that when there's a character or a string, okay, so I guess you can't really see that, but it's because it's so fast, but when the program first started, it's basically just printing a lot of new lines really fast here, so that basically goes off the screen. Yeah, so it printed this string. So if I do /bin/example dash d startup text string hi, that's not going to work because it parses that, and the shell interprets the quotes as literal constants. So you just need to escape it from the command line, and that, yeah, there. So you see it printed out hi. So then you can also change multiple variables at the same time. So for example, if I want to both change the acceleration and what else do I want to change? Maybe the initial position, so that's where it started on the board. Okay, if I change it to something like, you can 30, you can clearly see that it both started in the middle and it accelerated a lot more, so it accelerates whenever it bounces. So yeah, okay, so then also just kind of wanted to show off the type checking. If, for example, I accidentally say this variable, the character that shows up on the board, say I accidentally did that as a bool for some reason. Okay, so then if I run it again here, okay, so I printed out the startup text. So this is at runtime, so I didn't even recompile, and I could just change it. So it'll give you an error message. So incompatible type for configuration variable robot char. So it says it looked for a char because in demo app here it looked at, where is it here? Oh, here. So it looks for it with get char, but it found robot char and it was a bool, so it raised an error message. Or if I just take that out altogether and run it again, it says cannot find configuration variable robot char. Or also, if I defined it twice, oops, say I use $sign instead, it'll use the second value it sees, but it will also give you a warning. So in case you didn't catch that, since that goes by so fast, so let finish there. Okay. So it's kind of annoying. Yeah. So it gives you a warning. So at line 10 in the configuration file, it says that variable is already bound. So see here at line 10, it gave you that error message. Okay, I guess on. So if I give it something which is invalid, like that, it'll say syntax error when parsing configuration file /config /default at line 10, invalid value format. Okay, so yeah, so it obviously didn't recognize that. Yeah, okay, so then I guess also, I don't know if I mentioned that, but this is just like an example of using a hex number. So, I mean, this is the delay between renderings, I believe. Yeah, so it's usleep of delay millis times 1000. There's really no reason why you'd ever like write a delay or something like that as a hexadecimal number. I just did that just for example because I don't have anything where hexadecimal actually makes sense to use. But if you are doing something with hexadecimal colors, like you probably would be in your actual robot, that's something that comes in really handy. So you can just easily write a single hex number and then basically use bitmath to parse out the individual bytes and then pass those to OpenGL. Yeah, so I think that's all I have for the demo. Yeah, okay, so then something that's a little bit awkward is compiling this. The default version of G++ on the CSCI Labs computers is really old. So it basically to compile the configuration loader, or to get it to link properly to, it requires the boost regex library, which the default version of GCC doesn't support. If you you can do this with just doing module unload soft/GCC at the beginning of your session, but the thing is when the TAs actually run it and compile it when they're grading it, they wouldn't know how to do that. So basically, if you look at my makefile here, so this is basically just a simplified version of the one for the robots. So what this does, if you see the executable target here, so I run the normal compilation command, and then I basically I pipe that to /dev/null. So if it comes back with any errors, it won't print it out twice. But then, so this is basically so it'll work on your like laptop or whatever that doesn't recognize module unload whatever. And if that fails, it will retry it, but in a different way. So it runs tcsh, that shell. It runs that shell script, and I'm passing in compile as arguments. So this is a little bit awkward. But then if I just look at link.sh real quick, it's really simple. It just runs module unload soft/GCC, and then it runs whatever command you pass it in on your command line. So the compilation, like the final linking command here, basically will get run in its own shell, which just got the other version of GCC or G++ loaded. Yeah, so that's a little bit awkward, but you can more or less just copy this part and into your makefile. That might be a little bit awkward, but I don't know, it's also fairly straightforward. And I guess it's, if you run into any questions, feel free to ask on the forum about that. Okay, yeah, so then to actually use the library in your project or whatever, well, your robot, probably, there's a separate namespace named configuration. So in your header file, you'd have to do config table, or configuration : config table, config in your class. So like in demo app, I put in configuration : config table config. So basically I have a global private member variable in class demo app, which has which is a config table, and it's very important that it's actually named config so those macros will recognize it. Also, yeah, in your CPP file, you can also just always do using namespace configuration. And then in main.cpp, where is that? Yeah, so I guess I kind of already showed this, so you just include it there, and that's just one more thing you do is you load the config table in main, and then so demo app is basically corresponds to the simulation class in your robot class. So basically just add config table config to your constructor parameter and set that globally. So it should be pretty straightforward to change over to doing that. And in fact, if you are going to change over to using this for your project, you can even just replace them directly, the values that are defined, with get config of whatever variable you want to get, and without having to change it through the body of your code. If you get compiler errors like cannot find variable config or whatever, it might be a little bit confusing at first, but that basically just means that the config table isn't at scope wherever you're trying to load from it, so you just need to make sure that you have the config table in scope. And so, yeah, so config table is basically just, if I didn't mention that earlier, it's basically just a hash table which contains a bunch of names as strings and config values, and it's just a type def in configuration. Yeah, so then if you have any other questions, you can ask on forum, and I guess I'll try to reply to that. And yeah, this code that I showed today should be posted along with my tutorial. And yeah, so other than that, thank you for watching my tutorial.